pretty much any time I talk to someone about nuclear energy, they have one of two concerns. The first one, is nuclear safe? And to that I say yes. Nuclear is arguably the safest energy technology in existence, and future reactors are planned to be even safer. The second question, what about the waste? Well, and to that, I have a simple response for you. Nuclear waste is not waste. Did you all not know? I'm not surprised, especially with such an unfortunate sounding name. Why do we call it nuclear waste if it isn't waste? Well, most people don't spend their free time hanging out with nuclear scientists and posting about nuclear energy. But I do. I am a nuclear scientist. I have been enamored with the benefits of nuclear energy ever since I went to the nuclear chemistry summer school nearly 20 years ago. It's like space camp, but nerdier. And space camp is pretty nerdy. Nuclear energy is one of the most important tools we have in our clean energy arsenal. With it, we can power the entire Earth with low-emission electricity. We can even do space travel beyond Mars. There is a lot to be excited about with nuclear energy, but first, let's talk about this little waste problem. And like I said, the name's a bit of a misnomer. That's because only 5% of nuclear waste is waste. And it turns out that that's not even quite right. 95% of the energy value is still sitting there, waiting to be used. This would be like filling up your 20-gallon Ford Explorer, driving it for a few miles, pulling over to the side of the road, and siphoning out the remaining 19 gallons. This is madness. We wouldn't do this, but we do this every time we call nuclear waste waste. There's so much potential there. We just need nuclear recycling to help us get us there. And so before we nerd out on nuclear recycling, like I said, I'm a little bit of a nerd. I'm going to tell you some of the basics of nuclear energy so you can appreciate how cool nuclear recycling is. So nuclear energy basically happens when an atom splits and energy is released from that process. The energy that comes from the atom that is split is harnessed in the same way that we harness energy from a coal or a natural gas facility. We heat water to make steam to make electricity. Congratulations! You have now passed Nuclear Energy 101. So now, this material, once it splits, becomes really radioactive for a pretty long time. And we need to pull it out from the reactor because contaminants grow in that mess with the fission process. Now, this material that we pull from the nuclear reactors that we call nuclear waste is actually a critical energy resource. This is why instead of calling it nuclear waste, we could equally call it nuclear treasure. So now this nuclear treasure, formerly known as nuclear waste, at the atomic level is really just a whole bunch of elements. Most of them are uranium and plutonium, and you can make energy from them again, but a small fraction of them, that 5%, are these expensive elements like rhodium or palladium, or critical life-saving elements like medical radioisotopes. If we recover the material and separate the uranium and plutonium and put them back into the reactor, and then sell the expensive and life-saving elements, then nuclear recycling starts to make a lot of sense. However, we know that just recycling the material and getting it back into the reactor isn't the only problem, right? It turns out, as I mentioned, that this material stays radioactive for thousands, if not millions of years. But it turns out technologies could be changing that. The reactor is being built by the Bill Gates-backed company TerraPower up in Wyoming actually could change the life management timelines of this nuclear material from on the order of millions of years to more like several hundred. And if it's actually just back in the reactor making clean energy, then it's not collecting dust on the side of the building. So, recycling nuclear energy seems to make a lot of sense at this stage. And so you're probably wondering, why don't we do it? We understand the science. This should be happening. Well, there are two reasons why we don't. The first one is cost. It is just frankly cheaper to use fresh uranium fuel than our recycled nuclear waste. The other one is that many of the recycling technologies, some of our most developed ones, generate pure plutonium streams. That's right, that plutonium that has been used in nuclear weapons. The Treaty on the Non-Proliferation of Nuclear Weapons basically acknowledges that 5 countries have nuclear weapons. This is the US, the UK, Russia, China, and France. We also know that there are 3 countries that are non-signatories to the Non-Proliferation Treaty. This is India, Pakistan, and North Korea. And I think we can all agree that we don't want more nukes floating around. That's the entire point of the Non-Proliferation Treaty. Non-proliferation is just an unnecessarily fancy word that says, hey, everybody, can we please stop making more nukes? But if the plutonium that we recovered ends up in a nuclear bomb instead of a nuclear reactor, we could have a life-altering, earth-shattering geopolitical consequence on our hands. Like, literally. And this is the work that my research group is working on at the Colorado School of Mines. When it comes to the cost, it turns out that the biggest cost drivers for a nuclear recycling facility are the concrete and construction cost. And so if you can generate more efficient separations that generate less waste, you can actually build smaller facilities that are easier to construct and maintain. We do this in our research group by co-recovering all of the energy-producing elements, the uranium, the plutonium, and some of the elements that I haven't even mentioned yet, like neptunium and americium, in one step away from the expensive and life-saving elements. Such innovations like this could save tens of billions of dollars on the cost of your recycling facility. So now, what about this plutonium problem? We got a couple of different options there. The first thing we can do is actually just co-recover the plutonium with other energy-producing elements, just like I was describing. When we do that, we actually make a material that is much, much less attractive for making a nuclear bomb. Additionally, one of the most important things we can do is get plutonium back in the reactor so that it's being split into lighter elements that you can't make a weapon out of. That's right. If plutonium is in the reactor, you can't make a weapon out of it. The last thing we can do is just keep better track of the plutonium in the nuclear recycling facility. This is a lot easier nowadays with new sensors and digital technologies that we didn't have 70 years ago. And basically, they work like this. Many of you have cars, and you've probably seen a light come on, like an oil light, that lets you know if you're low on oil before your car engine explodes. Like maybe happened to me last week. And so, the main takeaway of this talk is that nuclear waste is not waste, but one of our most critical assets in our clean energy future. And some of you might still be a little bit nervous about the safety, and that's okay, because I actually have more good news for you. It turns out that the energy value that we have in our current used nuclear fuel, our nuclear waste, could power our clean energy future for hundreds of years. That's right. By using nuclear recycling, we don't actually need to make any more nuclear waste. And by then, they'll have sorted out fusion. And so, now we know that nuclear waste isn't a nuclear liability, but actually the nuclear treasure that can help our clean energy future. Thank you.